Hey guys, in this video, I would like to talk a bit on graphics capture tools. Some of the examples of the capture tools are GFXR Reconstruct and Windows Pix, and I use these a lot. There are other tools like RenderDoc, but in my work on with DirectX, I use GFXR Reconstruct and Windows Pix. So, what are capture tools? So capture when we run a game or any application, we can ask the capture tools to intercept the API calls and create capture files. These capture files contain the API calls, resources, and shaders, and any other state required to completely recreate the workload at a later point of time. So we can use these capture files to replay the workload, and the workload will be deterministic any number of times you play, and that helps a lot with debugging applications, games, and for performance analysis. In my previous videos, I have used Pix to debug what was going wrong with my mesh shaders, what was going wrong with my ray tracing shaders, and without those, I think it would have taken a much longer time to debug. So there are when Vulkan and DX12 came along, the capture replay tools have become immensely complex. Previously, the APIs like DX11 or OpenGL, they have a very high level of abstraction. High level of abstraction meaning app didn't have much control. All it could do was create resources and use the resources, create shaders or something like that. And it was pretty straightforward to capture the application, capture the APIs and the state, and then replay them. But once the Vulkan and DX12 came along, they exposed a very low level control to the application, in the sense that application can play with GPU virtual addresses. It can put the GPU virtual addresses in the buffers, and what is more complex is the shaders can write the GPU virtual addresses uh, into UAV buffers, for example. And the resource management in DX12 is also pretty complex because the virtual address is separated from the physical address, and the heaps, placed resources, they all pose huge challenges to uh, capture replay tool. And now we are going to talk about one challenge w- which these which DX12 APIs exposed. So this I took this pix capture from a D3 D12 example, dispatch culling. Sorry, it's D3D12 execute and direct, which does dispatch culling. So as you can see, this is a dispatch call, and the UAV buffer contains GPU virtual addresses and the draw arguments. This buffer is later consumed by an execute indirect. But the problem with having GPU virtual addresses embedded in the capture is because the capture time GPU VAs might be completely different than the replay time GPU VAs. Sometimes they might match, but once you restart the system, or some state changes, or you copy the capture to some other system with the same graphics card. I'm saying same graphics card because with different graphics cards we have a whole other set of problems. So anything changes, the replay time GPU VAs might virtual addresses might be completely different. So it is essential that the replay tool identifies these addresses and then uh, convert them to the replay time allocated addresses. Now the problem you see is these addresses are embedded in the buffer. So let's see more about what the application does, one scenario where it works and one scenario where it does not work. So this D3T12 execute indirect is the focus of this talk. So by default, the capture actually works because what the application does is on the CPU timeline, the application calls a dispatch, and then it immediately executes the command list, which means it submits to the GPU. Now the compute shaders execute and they actually write the capture time GPU VAs in the buffers. At this point, we cannot do anything because we don't even know that if it's a GPU VA or some valid data which should not be changed. Then, and at this point, the CPU waits for the GPU to complete. Now, when when the application tries to use this as an argument buffer in execute indirect, GFX reconstruct has at this point all the buffer is filled. So GFX reconstruct identifies this scenario and then it reads the UAV contents and then each of these, that is each of these addresses, sorry, it was the previous line, right? It goes through each of these addresses and maps it to the replay time GPU VAs. This is possible because the dispatch executes first and then the CPU waits and then the indirect execute is submitted to the GPU and just before submitting GFXR reconstruct gets a chance to change the UAV contents so that the addresses are now the replay time addresses. So let's see how this works. So this is scenario one, which is pass, right? So let's see. So first I will just do GFXR reconstruct and execute indirect. So this is first compute queue and then the GFX queue, right? So let's run this and spacebar to pause. So what we see here? The original address is A2B4900 and the replay time address also is A2B time. It's the same. So even if patching is not done, it would have anyway succeeded. So how do we simulate uh, the change at address change? So we have an option to create dummy allocations. So hyphen sorry, it's create dummy allocations. So what GeoFixer does is before any create resource, it creates a dummy resource so that the GPU VAs are not the same. Actually, if you go and look in help, it shows that this is actually for validation. So this is create dummy allocations, enables creation of dummy heaps and resources for replay validation. So that we have it says that we got a foolproof capture and foolproof patch, and it is not just working by chance. So compute GFX and let's just copy this create dummy allocations and then place the space bar to pause. So you can see that these are the capture time GPU VAs and GFXR has successfully patched the uh, replay time GPU replay time GPU VAs. And again, if we don't create dummy allocations by chance for these simple applications, they remain the same. And this is a case where you can so we can patch the addresses. So it is same, right? So 27FS0, 27. So there's no need to patch and it still works. By chance, if I restart my system, it might not work. I mean, it might need patching. And after patching, this scenario works. So what is the other scenario? The other scenario, I mean, games wouldn't want all this weights because we need to just have performance, the dispatch, and then the execute indirect has to happen without any wait in between. So the scenario is you call a dispatch and then on the CPU timeline, put some resource barriers, call execute indirect, and then execute command list and submit everything to the GPU at once. At this point, GFXR has no chance to map the VAs. So the end result is crash or corruptions. And again, it might appear to pass because, as we saw, GPU VAs might remain the same. So for that, I have scenario. Sorry, scenario two. Let's go fail, right? So let's see here. So I'm not using create dummy allocations. So direct. So this has only one queue, GFX queue, and then we just in this scenario we just do this. We just do a dispatch, execute indirect, and commandless. There's no waiting, nothing. Everything is submitted to the GPU at in one shot. So yeah, oh, sorry. I need to find it. Oh, okay, that's a fixed file. So here we see. Sorry, I'll execute again and I'll pause. We see that it is not able to patch. There's no original and there's no log is. Oh, okay, yeah. So we have original address and this is same, right? And this is the count buffer. It has no chance to map it has no chance to read all the other argument buffers. So in this case, what happens if we do create dummy allocations? So yeah, we see corruptions because there is a GPU VA mismatch, and without creating dummy allocations, the scenario 2 works because by chance the GPU VAs are same, but if we create dummy allocations, we see corruptions or crashes. Uh, Here I saw corruptions meaning there's no stars here because there are no draws for some reason. I mean, they're random values. As you can see, the original address and mapped addresses are very different. I think this is for the UAVs which can still be patched. But yeah, the the values in the buffers, there's no way that in this scenario the GFXR can intervene here and patch the addresses. So yeah, what could be the solution? We need to detect scenario to split the dispatch and execute. So this scenario, we need to make it like this scenario. We need to detect and then insert this stuff so that we can patch on the CPU timeline. But in this case, it appears to be simple. But in complex games, when we have thousands of dispatch and execute indirects, it is not an easy problem to solve. But it is good to know that such scenarios exist so that we can make a call whether to debug it in this way or find other ways to debug. So, yeah, that's it. Thanks, guys. Hope you find this useful.